Alright everyone, welcome back to Cody's Lab. So today is another video on making charcoal. I know, I've been doing a lot of these lately, but I've kind of been obsessed with charcoal recently. So anyway, I've had the barrel method that I've showed you guys in the last video, but a lot of people wanted to see me do the cone method where I dig a hole in the ground and then char the wood using, basically a method that doesn't use steel. So I want to know, is that better? Because I'm not burning wood in order to heat the wood, but I'm burning all of the wood. So what ends up being more efficient? I don't actually know, so let's find out. I'm going to load up the barrel with charcoal just like I did last time. I'm going to weigh everything, figure out how much wood I'm using to burn the charcoal, and then I'm going to take the same amount of wood and then use it for the cone method. I'll weigh the charcoal at the end and see which method is more efficient. Here's the empty trash can. Let's see what it weighs on its own. The weight might be a little different. I've got the scale sitting on a flat surface now, so looks like 14 pounds. That might be about the same as it was last time. Of course, it has lost a little bit of weight. You can see there's some scaling. I'm using the juniper wood again because I ran out of the hardwood. I've actually done this video twice. Kind of messed up the first time. Oh, it's still on fire. That's why the numbers were so low. It burned all night. Let me put that out. Here's the empty burn barrel. Let's weigh this as well. That's 40 pounds, maybe 41 pounds. It's actually a pretty thick barrel. Okay, the barrel is now full of wood. And we've got almost 70 pounds. It's like 68 pounds worth. Burn barrel loaded with the starting wood. Looks like we got 70 pounds total. 70 minus 40. That's 30 pounds of wood I got in there. I think that one I've got 54, so it's about half. That's about what I said earlier. Okay, let's set it up and burn it. Okay, getting it lit. I'm going to use this barrel here to measure the weight of the wood for the pit kiln. It's a little bit lighter than the other barrel, only about 26 pounds. Okay, now I'll go fill it with wood. Okay, what we got here? 110 pounds. That's it. Okay. I need the barrel. Looks like we're just about done. It's still hot, but it's done burning. Pull all these rocks off here. Toasty. Slide enough I can pick it up with one hand now. And we are almost 30 pounds exactly. Nice. So 16 pounds of charcoal. Let's open it up, make sure it was completely processed. Oh. Alright, looks like it's fully processed. It's glassy. And it all just lit on fire now that I give it oxygen, so now I gotta put it out. Okay, that should be good. Let's go work on the charcoal pit. Okay, so here we are. As you can see, I've dug a small depression into the ground. It's maybe a foot deep, and it's got really shallow sides so that the air can get in. And the idea here is I'll start a little fire at the bottom. Probably using some of this bark and smaller sticks to start with. And then, as that burns, I'll just continually add more material. The material on top will smother the material below so that it stops burning. And if I do it right, I should be left with a bunch of charcoal. That's the idea. And as for the material that I dug the hole into, this is actually a clay. And it's actually baked pretty hard from the last time I fired it. I find I don't get very much dirt in it when I'm scooping the charcoal back out. I figure you could do it anywhere. Ideally, it'd probably be in a metal dish so that you could actually spray it down with water without getting mud in it. So even spraying with clay would probably cause it to shatter and be muddy. Okay, fire is lit. Turn off the torch. Okay, you can see I've got a nice roaring fire going. The wood is turning into charcoal, releasing the wood gas, which is burning, producing heat, turning wood into charcoal. If I just let it go, the charcoal will start burning itself. But before that happens, I'm going to throw on some more wood. And I find that if I kind of just add the wood continuously, it doesn't make very much smoke at all, because there's enough heat and oxygen here to account for any moisture, and it just burns away all the smoke. So I'm definitely rooting for this method. See? No visible smoke. Also, I think it's actually faster at converting the wood. It's only been a half an hour and I'm already more than halfway through my pile here. Might have to stir it up a little bit at the end just to make sure everything did burn, because there are some thick pieces in there. But still, one problem it's got is it's producing a lot of heat. Like, it's kind of hard for me to stand next to it. Fortunately, my time-lapse camera is pretty good at dealing with heat. Okay, now that the flame's gone out, I'm going to shovel the coals up into this barrel, and then I'm going to go weigh them. I'm going to weigh them while they're still hot, so I don't have to worry about them burning away at all. See, I'm trying my best not to get any dirt in there. Like I said, I chose the clay for a reason. It's hard, it doesn't break off very easily. Okay, here it is. Put it on the scale, see what we got. It's like 29 pounds. Just balance on there. 29 to 30. Okay. Let's open this up. Dump in some water to put it out. So I happen to know that unless it's completely sealed, it'll just keep burning. What I have in there, we measured at 16 pounds. This one here, the barrel weighed just under 30 pounds, so it's about 15 pounds of charcoal in there. So the difference is like about a pound, not very much. In fact, the error bars on my measurements is at least a pound either way, so yeah, I'd say these methods are pretty much equivalent. In terms of like using the charcoal as fuel, all you really care about is the weight, which is all I've measured so far. But for biochar and stuff, you also want the surface area. So I'm going to have to measure that as well. So I've got a sample of each batch of charcoal here, and the first thing I need to do in order to determine the surface area is dry them out so that I'm actually weighing the charcoal rather than the water. This charcoal actually holds on to an amazing amount of water. The 5-gallon bucket that I dumped into the barrel to extinguish the charcoal was completely absorbed. None of the water dripped out. I ended up dumping another bucket of water onto it just to make sure it was completely extinguished. So to remove the water, I'm putting some of the charcoal into this little oven here. Get it as hot as I can. Okay, looks like I actually got it too hot and ignited one of the pieces of charcoal, which seems to have gone out on its own. I'll use a piece that didn't light. What I'm going to do is crush up a piece of this and weigh out 100 milligrams. I'm not going to crush it too fine, just so I don't artificially increase the surface area, even though I probably actually couldn't. The surface area of charcoal is just so great that even crushing it doesn't make much of a difference. Anyway, test tube tared. Okay, 106 milligrams of charcoal. So just like in my activated carbon video, I'm going to be doing a titration. Got some iodine solution, which I'll be using to absorb onto the charcoal, and a thiosulfate solution, which is loaded into the burette. I won't explain too much of what I'm doing. I've explained it before. The total volume in each test tube is 20 milliliters. So I'm going to take out half, or 10 milliliters, for the titration. Right there. Pinch of starch as an indicator. People seem to think I should do that. Assuming no absorption, this should take 5 milliliters of my thiosulfate solution. Hopefully it should take less. Clear. Okay, that's clear. We've used 4.5 milliliters of solution. Okay, I've reset everything. Now we're going to measure the Tort charcoal. Okay, that's clear. About 4.6 milliliters. Okay, so I've run out the numbers, and the charcoal that was made in the pit absorbed 30 milligrams of iodine per gram, and the stuff in the Tort 24 milligrams of iodine per gram. Something I'd like to point out about these numbers is the activated charcoal that you'd buy from the store for like fish tanks and stuff. When I did this same experiment with it, the values that came out was about 100 milligrams per gram of iodine absorption. That means that this charcoal here has about 1/3 of the surface area per weight that the commercially available activated carbon has. Which means you just use 3 times as much of it and you have the same filter capacity. So homemade charcoal really is pretty good. So I guess it's time for the taste test. Here's the charcoal made in the barrel Tort. Here's the stuff made in the cone pit. So I'll start with the Tort. Basically tasteless, like most well-made charcoal is. Got a nice crunch to it. It makes a nice squeak when it rubs against your teeth. It's not hard enough to scratch the enamel, but it is good for getting the deposits off your teeth, so I can kind of rub it around with my tongue. Now it's time for the stuff in the cone pit. Okay, so it's a lot softer. Turns into dust very easily. Kind of unpleasant to breathe in, talking while I'm doing this. Probably not a good idea. It's just not as strong. It crumbles much more easily. You see, the stuff made in the cone pit has got these little cracks running through it. You see there? The stuff made in the Tort does not have that. I can take the stuff made in the cone and just crush it with my fingers. Stuff made in the Tort, I cannot crush no matter how hard I squeeze. My fingers are just not strong enough. So that's one difference, which may or may not be beneficial in certain applications. So overall, I think that at least in terms of biochar, the cone method is simply better. It produces less smoke, it's easier, faster, uses the same amount of material, has perhaps even more surface area, doesn't use steel. There's a lot of reasons why it's better. Should make charcoal in the hole in the ground. Hope you enjoyed. I'll see you next time.